In this video, I'm going to talk about end behavior using limit notation, and I have detailed notes posted on Schoology that go along with the video. So you may be asking yourself, what is end behavior? And end behavior is going to describe how the y values of a function behave as x goes to infinity or as x goes to negative infinity, okay? And end behavior exists when the function is able to continuously travel to either infinity or negative infinity, right? Continuously travel without being obstructed by asymptotes. If the function cannot travel to infinity or negative infinity for any reason, then you can't have end behavior. Secondly, the function has to clearly approach a fixed value. It has to be clearly heading towards some specific number, or it has to be clearly heading towards infinity or negative infinity. So let's actually do some concrete examples to kind of help you understand. And I'm going to use the limit notation. All right, so let's say we have a garden variety parabola here. This is just a very boring parabola. Here's x, here's f of x, and let's talk about the end behavior. So I'm going to actually talk about left end behavior and right end behavior just so we can specify the difference. So left end behavior. All right, so let's talk about that. All right, this is going to, and I'm going to use the limit notation, take the limit as x approaches negative infinity. So it's saying, hey, if I'm going to travel to negative infinity, what's happening to the y value on the very end of the function? And you can see that the y value is heading towards infinity. So limit as x approaches negative infinity of f of x, that approaches infinity. That is the left end behavior. Similarly, if I want to know the right end behavior, okay, I can say, well, what is the limit as x approaches positive infinity, because that means I'm traveling to the right. Well, you can see the y values approach infinity as well. So this would be f of x approaches infinity. And in either case, we are allowed to have end behavior because the function can clearly travel to infinity, can clearly travel to negative infinity without being obstructed. Okay, let's take another example. And in this example, I want to do a square root function. So let's just pretend we have this. Right? X f of x. And let's look at the left end behavior. So I'm going to abbreviate, if you don't mind, LEB for left end behavior. So to have left end behavior, the function has to be able to travel to negative infinity, right? As I walk along the x-axis to negative infinity, I have to be able to physically travel there on the function. Well, notice the function doesn't even exist over here, right? So how can I have left end behavior if the function doesn't really exist on the left? So when I talk about left end behavior, I'm actually going to say none because I cannot travel to negative infinity. However, if I'm asking about the right end behavior, right, well, that's a different story. If I take the limit as x approaches positive infinity, I'm able to travel to positive infinity. The y values f of x approach infinity. So it's possible not to have any left end behavior or right end behavior, right? If I had the function reflected over the y-axis, similar logic would apply. Okay. Now, we are going to learn eventually about trigonometric functions, and you may have had some exposure to those in Algebra 2. So if I have a trigonometric function, so let me see if I can draw this properly. All right, it looks like a wave. We want to talk about whether this has left or right end behavior. So let's talk about the left end behavior first. So remember I said we have to be able to travel to negative infinity if I'm going to have left end behavior. And clearly this function continues indefinitely on the left. So I can travel to negative infinity, right? But the problem is if I follow the pattern, I continuously oscillate up and down, up and down, up and down between, let's say this is 1 and -1, right? So although I can travel to negative infinity, I do not approach a specific fixed value. I continue to oscillate indefinitely between 1 and -1. So theoretically, I'm going to say I have no left end behavior because I don't even know what the behavior would be. Is it 1? Is it -1? Is it somewhere in between? I'm constantly vacillating or oscillating up and down. Okay. Similar logic applies to right end behavior. Although I can theoretically travel to positive infinity, I do not approach a specific fixed value. The y values continue to oscillate indefinitely between two values. And there's no way to know where they end up heading towards. So again, I'm going to say none in this case. Let's look at another function. And again, we'll learn about these trigonometric functions later on in the year, but I'm just going to try to draw a function. This is going to be a tangent function. And that's okay if you've had no experience with a tangent function. We will learn all about those later on in the year. They kind of look like little cubic functions with vertical asymptotes. So I'm just going to draw them the best that I can. But this pattern basically repeats itself here. So again, if I'm looking at left end behavior, I want to ask myself, can I travel to negative infinity without being obstructed by something? And the answer is no, right? If I try to go towards negative infinity, I'm blocked by this vertical asymptote. So that's not going to work out so well. There's no left end behavior. And similar logic tells me that I can't travel to positive infinity without being obstructed by an asymptote. So there's no right end behavior. All right, let's take another example. This one is a very famous example of a rational function that you have learned about in Algebra 2. All right, let me see if I can draw this appropriately here. So I'm basically drawing this so the function approaches but does not touch the x and y axis. So that's a rational function. And let's talk about, does it have left end behavior? Okay, so let's talk about that. I'm going to see if I can take the limit as x approaches negative infinity. What does f of x do, right? What does y do? Well, as I approach negative infinity, doesn't it look like the function is approaching but never touching 0, where y equals 0? So here the left end behavior is the limit as x approaches negative infinity of f of x approaches 0. Whoops. Okay, because remember, you may remember from Algebra 2, if this is y equals 1 over x, y equals 0 was a horizontal asymptote. We approached it, but we never touched it, okay? And similar logic applies to right end behavior. If I take the limit as x approaches positive infinity of f of x, what's going on? Well, f of x clearly approaches 0. So this is going to be the limit as x approaches infinity of f of x approaches 0. Okay, I hope that helped a little bit. I have detailed notes on this as well, and we are going to do a practice on Schoology for end behavior. So please let me know if you have any questions while you complete the practice.